Welcome to question 2 of the 2017 Mathematical Methods Exam 1 for the Southern Hemisphere. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. So for question 2 we have let y equal x times log e of 3x, and for part A we're asked to find the derivative dy dx. So if we consider this expression, it's two functions multiplied together, so we're going to need to use the product rule for differentiation. So to apply the product rule, I'm going to start by letting u equal the first function, which is x, and v equaling the second function, which is log e of 3x. And then we need to calculate du dx, so the derivative of x is simply 1, and dv dx, and the derivative of log e of 3x, this is one where a lot of students will make errors. It is just 1 on x. So then from the formula sheet, we know that the derivative d dx of a function u multiplied by v is equal to u times dv dx plus v times du dx. So therefore, dy dx, the derivative that we want to calculate, is going to equal u, which is x, times dv dx, which is 1 on x, plus v, which is log e of 3x, times du dx, which is simply 1. And then doing a little bit of simplification gives dy dx is equal to x times 1 on x is just x on x, which simplifies to 1 plus log e of 3x. So that is the answer to part A of this question. So from the examiner's report, we can see that most students used the product rule, which was required on the previous slide. However, many students made an error when they went to find the derivative of log e of 3x. And common incorrect answers were seen to be log e of 3x plus 3 and log e of 3x plus a third, which went to show that they really didn't know how to differentiate the log e of 3x expression. For part B of this question, we have hence calculate the definite integral 1 to 2 of log e of 3x plus 1 with respect to x, and we're asked to express our answer in the form log e of a, where a is a positive integer. So to tackle this question, we need to look at the word hence and see that that invites us to use parts of our previous answers to answer this question. And the part of the previous answer that we're really interested in was the fact that the derivative of x log e of 3x was in fact equal to log e of 3x plus 1. And now if we were to integrate both sides of that equation with respect to x, we would still have an equal statement, which means that we know that the integral of log e of 3x plus 1 with respect to x is equal to, and the integral and the derivative on the left hand side up here will undo each other, so we just have equals x log e of 3x. And now if we want to go between 1 and 2, we simply evaluate the antiderivative between 1 and 2, and to do that we're going to substitute in the upper terminal and then subtract away the lower terminal substituted in. So this is going to equal, and substituting 2 into there, we'll have 2 log e, and we'll have 3 times 2 is 6. And then we subtract away the lower terminal substituted in, so 1 subbed in for x will just give 1 times log e of 3 times 1 is just 3. And now we need to use our knowledge of log laws. And the first property that we'll use is the fact that if we have a coefficient to a log, we can put it up as a power, so that will be up here. So that will give log e of 6 squared minus log e of 3. And now when we subtract two logs with the same base, so in this case the base of e, we can simply divide the argument. So 6 squared is 36 divided by 3. And now that is going to equal log e of 36 on 3 is simply 12. And that is the answer in the correct format for this question. From the examiner's report, we can see that 45% of students got full marks for this question. However, the examiner's report does go to say that students were generally not able to form an integral from their previous answer because many ignored the hence instruction, which was so important for this question. Some students attempted to integrate the given expression directly, which was not possible, and some poor application of log laws and or log notation was observed throughout students' working.